Good day, grade 12s. Welcome to Math Masterclass class. Today we are doing mathematics. We're focusing on quadratic, arithmetic, and geometric sequence. By the end of this lesson, you will be able to calculate the nth term. You will be able to distinguish the quadratic, the arithmetic, and the geometric sequence. You will be able to calculate as well the position of the terms. Right? Okay. So we're going to begin our lesson with a quadratic sequence. What is a quadratic sequence? What is a quadratic sequence? A quadratic sequence is a sequence in which the second difference is constant. The second difference is constant. So what do we mean when we say the second difference is constant? Okay, I'm going to take you through the example and show you what we're talking about when we say the second difference is constant. Am I right? Okay, consider we're given this pattern 5, 11, 21, and 35, right? So we're going to look for the first difference first, and then we'll find the second difference, right? So how do we find the first difference? We're going to say T2 subtract 5, that will be 6. And then we're going to say T3 subtract T3 subtract T2, that is 10. And then we're going to say T4 subtract T3, and then that is 14. Right? So this is what we call our first difference. This is our first difference. So the first difference in a quadratic sequence, it is not constant. So now, according to our definition, the second difference of the quadratic, it must be constant, and then we can conclude that is our quadratic sequence. So now let's look for the first difference. What are we going to do? We're going to subtract the first difference so that we can get the second get the second difference. So now we're going to say 10 subtract 6, that will be 4, and then 14 subtract 10, that will also be 4, and then this is what we call our second difference. This is what we call our second difference. Alright, so now the second difference is constant because we got what? Because we got 4. It's 4, it's constant, same numbers. So now we can conclude that our pattern is a quadratic sequence. So okay, moving forward, we're given a formula here. That Tn is equals to an squared plus bn plus c. This is our quadratic formula. So now, what does n mean in this case? What does this n mean? N is the position of the term. N is the position of the term. What do we mean? 5 is in position 1. So how are we going to represent it? N will be equals to 1. And then what does it mean? That simply means T1, which is the first term, it's equals to 5. That's what we meant by n equal to 1. So now, okay, for the second example, 11 is in position 2. Am I right? So our n here will be equals to n equals to 2. Then how do we represent it? We're gonna say T2 is equals to 11. Am I right? So that's how you're going to represent that. Then going forward now, how do we get the value of a? How do we get the value of a? How do you get the value of a? A is a number, A is a constant. Here we're given a formula. A is equals to half of the second difference. It's half of the second difference, right? And then A will be equals to half of what is our second difference? It's here. It says it must be the second difference. So here is the second difference. So we're going to substitute our second difference, which is what? Which is 4. And then we'll put 4 in here. And then we can close our brackets. Then that will be 4, and then our a will be 2. All right. So now we found a. What is our a? Our a here will be 2. Right? Okay. Let's move forward. How do we get the value of b now? How do we get the value of b? Let's calculate the value of b. How do you get the value of b? It's gonna be 3, and then what's happening? We're gonna have a. A is calculated above. That will be a, right? And then we're gonna see 3a plus b, which is equals to T2 minus T1. Am I right? So now let's substitute. We're gonna say 3a into a. We calculated it from above. That will be 2, and then going forward, it's gonna be plus t plus b, which is equals to T2 minus T1. Here it's our T2. T2 is equals to 11, and then T1 is equals to 5. Got them off there. So T2 is 11, then we subtract 5. Right? Okay, so then 3 times 2, that will be 6, plus b, which is equals to 11 minus 5, that will be 6 also. Alright? Okay, and then b will be equals to 6 subtract 6, that will be 0. right? So now we calculated the value of B. We calculated the value of B. So our B in this case will be 0. We found the value of B. So we're going to use this. How do we get the value of B? And then this is the formula we're going to substitute in. A, we have calculated A from above here. So we're going to substitute. We have T2 and then we have T1. Am I right? Okay. So going forward, how can we calculate the value of C? How can we calculate the value of C? Okay. So calculating the value of C, the formula is this one here. So we're going to say A plus B plus C is equals to T1. Right, and then we have term number 1 here. We have calculated the value of A, and then we have calculated the value of B. So we're just going to substitute now. Right, what is our value of A? Our value of A, it's 2, so it's gonna be 2. And then what is the value of B? The value of B is 0. So now we're going to substitute 0. Okay, and then going forward, we're going to add B because we're looking for B, which is equals to, and then what is our T1? Our T1 is 5, and then we're going to say B is equals to, take that, we add 0 plus 2, it's 2, and then we take 2 to the other side, it will be 3 minus 2, that will be 3. Oh, sorry, oops, that's not B, that is our C. Oops, sorry. Okay, yeah, that is our C. That is our C, we got B here, right? Okay, and then now we're going to say Tn, our general formula, it's equals to A squared plus Bn plus C. So now we have found our nth term. So what will be our nth term? We got A, therefore our nth term will be 2n squared. Our A is 2, and then plus our B. Our B is 0n plus 3. So we can represent this like this. Therefore the final nth term will be 2n squared plus 3. So we're done now. This is our nth term. This is how we get the value of A, B,